Hell no. No, that would be a very bad idea. So authorization can happen on average for a microservices based application 3 times per request on average without you even doing anything. So if you do a cloud kind of back and forth for every microservice access, you'll be killing the performance of your application very fast, even if you have CDNs or optimization on the connection there. So the way it works is that we provide you that microservice for authorization, and that runs locally within your VPC. Ideally, is a sidecar next to the microservice you're catering to.
Or Weiss, welcome to Software Engineering Daily.
It's a pleasure to be here. Thanks for having me, Alex.
Awesome. So you are the co-founder and CEO of Permit.io. You've been on Software Engineering Daily before. You were here in August of 22. But for those that missed that one or anything like that, can you just give us a background on who you are and what Permit does?
Yeah, sure. I'd be happy to. So as you've mentioned, my name is Weis. My background starts as an engineer in the intelligence core in the IDF in a unit called 8200, which people must have heard of by now because we're not as good with keeping secrets as we used to have been. Afterwards, I worked at a couple of startups. I was in a startup that built containers before containers were a thing, but with a really bad go-to-market. I was a VP of R&D in a cybersecurity company. And before Permit, I worked in a company I co-founded and ran as CEO, a company called Rookout, which is a production debugging solution. Still on the board of that company. But working on it, I ended up rebuilding the access control for the product 5 times when the company wasn't even 3 years old. And that basically drove me insane. I didn't want to build it once, let alone 5 times. And it kept surprising me. And I realized that has become a huge annoyance and pain point for developers. Instead of being able to focus on your product, you're focusing on this crap. So that's basically the premise with Permit, the idea that you'll never have to build permissions again. You bake Permit into your product, you get a ready-made microservice for authorization, SDKs and plugins for your API gateways and other pieces of software, and the ability to control it all from a unified control plane that generates policy as code, but from an interface that a monkey can use, or maybe even a product manager. So you can delegate that to other people. So when they come in knocking at your door saying, oh, this user, unless we had another role for them, like another billing role, they're not going to buy. So instead of saying, okay, let's do another sprint of development to add a role to the system, you tell them, go into Permit, click on create role, and leave me dev alone. I have actual features to build. So that's me and Permit in a gist.
Awesome. I love it. I love the background. I want to talk more at the end, just like on your journey as a founder and what you've learned from that. I know Rookout, a very cool company there. So
Thank you.
I'm excited about that. But like, I want to talk about Auth because I feel when I talk to developers, there are two areas that they sort of scratch the surface on, but there's just so much depth that they don't know about, and that's data on one hand, and it's Auth on the other side. And I'm excited to be talking to an Auth expert just because. Honestly, for me, I'm excited to know some of this stuff. So, first of all, I say Auth. What do we mean by Auth? Like we talked a little bit before, like the 3 categories of Auth before this call. Like, what is Auth when we're talking about Auth?
That's a terrific question. So I like to kind of break this down as part of the IAM space, identity and access management. And essentially, it's comprised of a cascading waterfall of 3 layers. The first one is identity management. So things like Azure Active Directory, Okta, Ping Identity, solutions like that, where you manage the identities of the organization on the from the vendor perspective on the customer side. Then we move to authentication, which is verifying your identity often against the identity management. And there we have common solutions like Auth0 and Cognito on AWS and Magic and Super Tokens and FusionAuth and like a bazillion solutions today. And then we move to authorization. So we have authentication and authorization. Both are referenced as auth, but one is authn and the other is authz. And people confuse them even just because they sound alike. And while authentication is about verifying the identities, authorization is about deciding what they can do or cannot do within the solution. Authentication you do once per session or per sessions, and then usually you get a JSON web token, and that kind of carries the identity throughout the application. Authorization you need to do per request, because the world picture and policy can change in between. So very, very different, even though they sound the same. By the way, there are other things that cause the confusion. So for example, in HTTP, there's a header where you pass your authentication token. That header that has the authentication token is called authorization bearer token, right? So these are like things that are kind of legacy that we carry with us, but they keep confusing us till this day.
It's truly confusing. So just to make sure I have this right, authentication, that's when I enter my username and password, right? And if I'm signing into Twitter or Instagram or whatever, I'm signing in doing that. That's authentication. Authorization is, even if I'm authenticated, they know who I am. I can't post a tweet to your timeline. I can't post an image on behalf of Weis because I am not authorized to do that, right? Only the person that's sort of authenticated as Or.
Correct. With authentication, it's definitely the most common thing that people know about is logging in, and that user and password interface, or that login with Google, Facebook, whatever, that's called OAuth. Yep. For logging in, but it's actually becoming different now with WebAuth and other technologies like that. Logging in through your biometrics or through a YubiKey or other kind of secret storage that you might have with you are becoming additional common places to log in, as opposed to just managing users and passwords, which can be, let's say it can create a lot of chaos as people are not as good with keeping passwords and managing them and coming up with good ones.
Yep. Wait, okay, so tell me what WebAuthn is. Is that the biometric stuff specifically, or what is when I've heard the term WebAuthn, what does that mean?
So it's a protocol to communicate additional data in a secure fashion from the device you're running on by having a chain of trust between the device itself, the browser, and the website or application accepting the authentication parameters. So there's like this chain where everything can be propagated securely, and it can even harness specific hardware for encryption that is now available on devices. Basically, a secret storage as part of your CPU or otherwise hardware infrastructure.
Very cool. Very cool. Okay, I'm going to talk more about that stuff at one point, but I want to move deeper into access control, because I know there are like different groups of access control and more acronyms. I hear ABAC and RBAC and REBAC. What are these different forms of access control?
Yeah, that's also a great question. So those are policy models. And even before we dive into them, it's important to understand that in nature, in the wild, no application is just pure one model or another. These are just boxes or templates that we can use to think about how we build our policies. There are some cases where you are very close, or for a while you're spot on the model, but most often than not, your application would be a mixture of different models and policies. And let's maybe start chronologically, like where everyone starts. You're a developer, you're writing your first service or your first feature in the product, and you need to gate access to that. You often start with hard coding an if condition in the code that just says, you can do this if you're me, the developer, and otherwise you can't. And that's called admin, not admin. And that's probably the most common policy model in existence. Everyone does that at some point or another. And sometimes you can even stick with it for a while. And that usually changes when other people start using the product, or other stakeholders that manage the product with you start to ask to be able to do things, those silly bastards. And then you often graduate or at least move up into a model that I like to call admin, not admin, and super admin. So you escalate yourself to be the super admin. That's usually still hard coded. And the admin, not admin list, now that's, you just throw it into the database. There's like a table of the users, and each one is a field, like if they're an admin or not. The admins can change the settings for others. You can do whatever you want because you're God, you're the developer, and screw everyone else. And then
I want to stop you right here. Because I recognize this pattern. I have implemented this pattern. I didn't realize there was official names for this pattern. So that makes me feel a little better in terms of that, right? Okay.
Yeah, you know, we all share the hardship.
Yeah,
So that's something, if not nothing.
Yeah.
So you do that, and then usually when you start to have actual customers, and now they have requirements about how they use their product, and maybe they have different people that use the product. That's when access control lists will start to fall in. So you basically have a list of features, and for each of them you have a list of users who can use them or not. Access control lists are also or ACLs are also are very familiar from from operating systems. Like in Linux, the way you assign permissions to files is usually through ACLs. That's how that's structured. Or on the file system, it's with ACLs. But usually, very quickly from there, you move to what I like to call the bread and butter of the authorization space of permissions, and that's
And to stop you there, so when you're talking about ACLs, am I into a multi-tenant world yet, or am I still in like sort of a single tenant world where maybe there's different groups within that tenant, you know, but still mostly single tenant, or can that work in a multi-tenant world as well?
I think ACLs are, well, it can work both multi-tenant and single tenant. ACLs, you'd still probably see them more they're kind of old school. So you'll see them more in monolithic single tenant systems. But it's basically independent. The concept of multi-tenancy is another layer that you can apply to any authorization model or policy. So now we're coming at RBAC, role-based access control, which is literally, as I like to say, figuratively, the bread and butter of the authorization space. It's the bread and butter because it's very simple. Everyone knows what our role is at this point, and everyone has seen it in a different application. So often your customers would request to have roles in the system just because they're accustomed to it, just because they've seen it in other systems. So it's almost, once you start catering to businesses, it's almost inevitable to arrive at role-based access control. And role-based access control basically means that you assign labels, roles to people. So that's now the property that you manage in the database, let's say. And you check you translate a user, you translate an identity to a role. And then according to the role, you assign permissions and you allow them or deny them to do certain things. Here is also somewhere a point where people have a lot of confusion with authentication, because authentication solutions also have roles. So is that authorization or is that authentic? What's going on here? So the basic answer is that RBAC is so popular that people kept asking that from the authentication vendors, so they added that in as well. But it boils down to, with authentication, to claims in the JSON Web Token. Maybe we should cover that quickly. Yep. So a JSON Web Token is a cryptographically signed document, a JSON document, that one of its fields is a signature on the body of the rest of the document. Through that signature and through knowing the public key that the signature was generated with, you can verify that this token is signed by a authority that you trust, for example, your authentication provider. So you don't need to constantly regenerate this and go and check your authentication provider. If you see this document and the signature checks, you can say, okay, the information here is valid and the identity that is described by this document is the real deal. You can think of the JSON Web Token as essentially the passport that Also, that's why then there's that framework in Node.js called Passport that does authentication. That's essentially that. So that document is what the user carries with them across their interactions with the application. Usually it's propagated either as part of the headers, the HTTP headers, or as part of the cookies, which is also a header. So kind of the same thing. So you have the JSON Web Token, and now your authentication vendor can plug in additional attributes, additional items about the identity as part of that document. So for example, you can shove in a role there. You can say this user, I decide at the login stage that he's an admin or an editor or a billing user or whatever it is that you have in your Snowflake application. The problem with that is that now you've coupled the identity and with the patterns of the logical application itself. So first of all, if you change things on the authentication layer or in the application, now you need to have a contract between them. It might break. And now also, if you want to change this, you have to re-log in the user. The concept of logging in is having that document. So every time you want to change something, you need to recreate that document, which can also create some friction and bad performance flows in the application. But that's the least of evils that people do there. Sometimes they literally load all of the rules or all of the routes that you should access in the application into the JSON Web Token. They basically turn it into a database. And that doesn't work well because you're sending that document for every request. So that adds a lot of weight. And also it makes it really hard to do dynamic changes. And so in general, that's kind of a pitfall and an anti-pattern.
Gotcha. And I want to ask on this because I had some questions about JWT because I see people in the auth community kind of argue about, hey, you shouldn't use them at all, or you should use them, you shouldn't use them, or you should use it, but you shouldn't add all this stuff in it. So do you have an opinion? Like, do you recommend JWT, but not with
for sure.
garbage in it? Okay, is that your preferred method?
Yeah, JWTs are the standard practice to manage identities in your application. They're the best thing we came up with for authentication since sliced bread or identities in general. But we just need to keep in mind what this thing is. It's your passport. It identifies you. You shouldn't have your policies or your attributes about the application itself inside your passport. Like when you're flying to another country, you don't come in your passport all the things you want to do in that country, right? That would be weird. Sometimes you can add a visa that's kind of like borderline, like general guidelines on what authorization should do with you. But it shouldn't be like the strict decisions of like, you can step into the airport, you can step into that room, you're not allowed in that city. That would be just too cumbersome, even in the real world metaphor.
Yep. So do you not like anything in a job like that's authorization related? Like, would you be fine with a role and that's it, or do you think not even that should be in your job?
So even a role, I'd say the role, if you indicate a role, it should be your organizational role, which is something that is part of your identity. Because being an admin in an application is something that is most likely volatile. It's dynamic. You be assigned it on the fly multiple times, even in a minute. But the role that you have in your organization, like if you're in the marketing department or in the R&D department, those are things that are less frequent to change and are closer to be part of your identity. So also things like what is your nationality, or where do you work, or things like maybe more sensitive things like your age, stuff like that. Those can go there. But in general, if it's not part of your identity, it shouldn't be in your identity document, which is what the JSON Web Token is meant to be.
That's a nice way to frame it. That's helpful. Okay, cool.
Yeah. And what does happen there is a translation or hints from the authentication and identity management layers into the authorization. Those are called claims. Basically, these are things that the authentication provider claims about you. Say, oh, you have blue eyes and you work in the marketing department. Those are things that I claim that are true, and I put my signature on it, verifying that. Now we have the opportunity to translate those into application level concepts. So let's even start. So the identity management, let's start at the beginning. The identity management, the Okta, for example, for the customer, for the organization, lists you as part of the marketing department. Now we're moving through SSO, through XAML, for example, into the authentication layer, which is part of the product that you as a vendor, you as a developer are building. And then it moves to authorization. So now you're translating concepts that come from the customer side into things that are in your application side. So you can write logic there as part of the sign up phase or logging phase that do that translation. So for example, if you are part of the marketing department, you should have the editor role in the application. But there needs to be some kind of contract or some kind of logic that does the translation. And that's called, by the way, entitlements. The policies that translate identity or other patterns into roles or attributes that will affect your authorization down the road. And now this is all we're under. I remind you, we're under the umbrella of RBAC. Yeah. But we've covered the basics of concepts around RBAC here. And RBAC can take you very, very far. It's one of the most beloved and commonplace policy models, but it's not enough. Not everything is a role. So for example, a common policy that people want is only users that have paid for a feature can use that feature. So we can try and address that from an RBAC perspective. That means that we'll assign to you a role like paying user. So now you have a paying user role and an admin role and maybe something else, but having a role of paying is kind of weird. Also, what if we have different levels of payment? So we'll have different roles for that. So that doesn't make much sense. And also there are even more dynamic attributes like your geolocation. I'm not talking about your residency. I'm talking like, where are you connecting from right now? You might be traveling. You might be crossing the border as we speak. The time of day, all of these are dynamic attributes that can change on the fly, but you might want to have them as part of the policy. You might want to say only paying users that are currently in the continental US should be connecting to the US servers, and everyone in Europe should be working with the European servers. For example, if you want to address GDPR, that regulation around data privacy in Europe. Yep, sure. So roles are not really the way to do that because this changes very dynamically. So this is where ABAC comes in, attribute-based access control. When you boil it down, ABAC is basically a bunch of if conditions, a bunch of checks on attributes that either your identity has, the application resource has, or the general context of what's happening now. In Permit, by the way, we actually created a concept that enables you to work with ABAC like RBAC, and we call that a user set. A user set is basically like a role, but instead of being defined by a label, it's defined by a set of conditions. And equivalently, there's a resource set. And instead of being a predefined resource, it's a resource that's defined by its attributes. And you can literally go and say, I have a user set and I want to click on some checkboxes, and that will give you the permissions if those conditions apply. So that's ABAC. And sometimes even that's not enough. Sometimes you want to describe hierarchies or nested relationships. That's where REBAC comes in, relationship-based access control. So let's say you want to describe something like ownership. You can only use a file, you can only read a file or edit a file if you're the owner of it. So there's the concept of a file instance, that's a specific resource. And now we need to be able to say that you're related specifically to that instance, that you have an ownership relationship with it. So you can do that as an attribute. So for example, you can imagine having in your user profile an attribute of all the files that you own. Or you can put it on the file and have the file list all the users that can access to it. Another way to describe this that is very common in computer science is a graph.
Yeah.
And this is especially helpful if you want to have nested relationships. So you can access a file if you own the file, or you own the folder that contains the file, or the folder that contains the file. So you want to have basic recursion there. You can apply this both with ABAC, but reback is the more natural way sometimes to do that. Essentially, reback is a subset of ABAC, a more focused subset of ABAC. And with reback, you also have implementations that implement your policy as a graph. In general, today, as you look at the authorization space, there are two camps. There's the policy as code camp and the policy as graph camp. And they have pros and cons. At Permit, we're actively working on merging the two so you can enjoy both worlds. But in the interim or outside of Permit, it's a decision you need to make. Is my policy more around hierarchies and nesting, or is it more about dynamic attributes? Am I going to manage millions of users, or am I going to manage hundreds of thousands? And then you get different performance profiles for the two.
Interesting. And what are those two camps? Both on the sort of number of users, and then the more hierarchical versus attribute. Like which one goes into policy as code versus policy as graph?
So to name some projects, so the policy as graph camp is led by Google Zanzibar. Mm-hmm. Google Zanzibar is a white paper that Google published on how they do authorization for things like Google Drive, YouTube, etc., etc., etc. So and that in Google Zanzibar and its open source implementations, not from Google but from other companies good companies that went about to implement that. That's really good for managing if you have a lot of users and you need a very simple reback policy. So if you have something like Google Drive or YouTube, where you basically have a lot of files that are nested under each other, and you need it to be accessible to a lot of users, then that's a good solution for you. Like if you have more than, I'd say, 10 million active users engaging with your resources, that's probably where you should look at. But you'll be limited to...
Is Zanzibar more the policy as code or the policy as graph camp?
Policy as graph. Reback and policy as graph.
Okay.
So you'll have the advantage of a simpler policy and greater scale and consistency, but you'll be limited by which policies you can write, and it will require you more scale to handle. And in general, you'll have less. Your general performance would be not as good. The policy as code engines can deliver better performance in general. And these graphs that end up being like huge graphs that you need to manage provide more latency, especially if you're consuming them from a third-party service.
And so is Permit a policy as code, more than policy as code? I understand you're trying to merge those a little bit, but more than policy as code camp?
So we started with the policy as code because it applies to more companies. Mm-hmm. Most companies don't have tens of millions of users that they're managing. They have sub 1 million users. But they have complex policies that they want. They want ABAC and all the different flavors that you can think of for that. Yeah. And there are, by the way, also other advantages of policy as code. All the best practices of managing something as code. So we've seen that really blossom in the infrastructure as code space. Being able to have tests, being able to have benchmarks, being able to manage it with ease in one single source of truth as a Git repository. Those are a lot of the good things that you get from policy as code. And not as much when you manage it as a graph. You can like download a subset of the graph or the relationships that the graph represents, but it's harder to do.
And is that because the policy as graph is like sort of messing with actual resources? Like you're sort of pulling down information about the resources themselves, or even like the hierarchy of the resources? Or am I misunderstanding?
The hierarchy of the resources and the almost inevitable focus on instances as opposed to types.
Gotcha. Yeah. Okay. So if you have policy as code, you have that in your repo, like, and you're doing more of like an ABAC type thing, like how many distinct attributes will like a common permit customer have? Is it tens? Is it hundreds? What is that sort of order of magnitude? Or is that the wrong question?
It can really vary.
Yeah.
I'd say around the hundreds, or sometimes we also see thousands. Some we have customers that are just doing very basic RBAC with a little bit of ownership or a little bit of tenancy, and then there are not a lot of attributes. But others can really go wild.
Yeah. Cool. If someone tried to, I guess, use if they had a more policy as graph use case, could they still use permit, and would they just run into issues with it, or what would that look like?
So one of the unique things about permit is that we're agnostic to the technology itself. So we created an open source project called Opal. Opal is Open Policy Administration Layer. So we started to have it manage OPA, Open Policy Agent, which is a very popular policy engine. But Opal is also it's an abstraction component. It allows us to work with different policy engines and stores without tailoring each of them. So while we started with OPA, we're already working with some other engines and can also work with implementations of Google Zanzibar. And down the road, through both the abstraction of that bridging component and the abstraction of the interfaces that we provide. So we provide the policy editor itself that generates the policy for you, both through an API or a UI. We generate the user management interface for you. So because we provide the interfaces themselves and the bridging components, we can, in a way that is transparent to you as a customer, we can add more interfaces for you. We can add more databases in the background, and you just enjoy more capabilities without having to change anything on your side. So we're already doing a little bit of graph-based for our basic reback support, but there's a lot more coming in that area.
Cool. So you mentioned the policy editor. In your experience with the customers you have, who is generally creating the permissions or the policies, and how are they creating them? Are they creating them with the editor? Are they creating them more in the GitHub repo, just authoring themselves? Like, what does that flow look like? Who's involved with defining that?
Yeah. So maybe first let's tighten the loop around that. So we have a policy editor where you can, in a way that is very simple, that a monkey can use or a product manager can use, as I said before, you can create roles, you can define resources and actions, and you just check boxes to assign permissions. And you can create user sets and resource sets to also do the same thing for ABAC. And that, when you do that and when you click save, that generates new policy code in Rego, the language that runs on top of OPA, which is kind of like Datalog or Prolog. And that gets pushed into your Git repository. And then through Opal, the open source project that I mentioned before, it gets propagated to the thousands of policy decision points, microservices for authorization that you might have deployed. So that's the basic flow there. And then different people can chime in on the process in different points. So early on, when you're just building this would be a tool that the developer would use, just to kind of set up the basic policies, test out the concepts, see that this is suitable for the application. And they can go through the flow and then add tests on the GitHub side. So you generate code, you see that it's good, you add more code on your own, and you can iterate on that with ease. But then there comes a point where the application is ready, and now you need to kind of do the business flow. You need to cater to the customers. You need to adjust for the different scenarios. You need to do support. You need to do sales and enablement. And so instead of the developers becoming a bottleneck there, every time a new role needs to be added, a new permission needs to be checked, instead of opening a ticket, you just give this tool, the back office, with the right permissions. And here we're starting to touch on authorization for authorization. We'll circle back to that. You can delegate this to the product managers, to the salespeople, to support, to compliance, to the professional services or solution engineers. They can work with this while you as a developer keep all the guardrails. You are the one that controls the Git repository that ends up boiling everything down to what actually happens. But you don't have to be involved in every little step, and you can automate a lot of that flow as well,
Awesome.
of the testing it.
Awesome. So you mentioned how when you sort of author anything, gets to GitHub repo and then gets sort of distributed out to these decision points. I looked on the homepage. I see sort of the code of using permit, right? You're doing like permit.check and basically passing in an identity and some kind of action, what they want to do.
Right.
When I call permit.check, what is happening? Is that making a network request to permit IO? Like, what's going on
Hell
there?
no.
Yeah.
No, that would be a very bad idea. So
okay.
authorization can happen on average for a microservices based application 3 times per request on average without you even doing anything. So if you do a cloud back and forth for every microservice access, you'll be killing the performance of your application very fast, even if you have CDNs or optimization on the connection there. So the way it works is that we provide you that microservice for authorization, and that runs locally within your VPC. Ideally is a sidecar next to the microservice you're catering to. And when you do that query, it talks directly to that sidecar, which answers through the agent deployed in it, usually OPA. It answers directly from the memory cache that it has there. So you're going from your service through the loopback adapter to memory. So it's basically memory to memory. We often see that these queries are sub 10 milliseconds.
Gotcha.
So you don't need to be cheap around them. So you can add authorization checks so your application will be secure, and you don't need to worry about hurting your application's performance.
Gotcha. And so all the data that's needed to do that auth check is distributed to these agents. They don't need to reach out on a given call. It's all sort of available locally.
Yeah. So that's what Opal, the open source project that we created and is a component within Permit, does. So Opal tracks your Git repositories for policy, and it tracks data sources that you define for data. And what it does, it sends instructions to each of the microservices for authorization to collect the data that they need to be able to answer authorization queries. And it's extensible. They're what we call data fetch providers. These are small Python modules that you can create to teach Opal how to connect to whatever data source that you have. There are already ready-made ones for HTTP and Postgres and LDAP and a bunch of stuff. But you can always customize it to whatever data source you are using. And the beauty is that each component is independent. Each microservice for authorization is responsible for bringing itself to the state that it needs to answer authorization queries. It's basically a replicator pattern, and it replicates everything in memory, so it can answer things in a performant manner. We basically, one of the things that brought us to build this way is inspiration from Netflix. So Netflix have adopted OPA early on to build the authorization for their applications. And they started with this replicator pattern. They call it a distributor as part of it. There's a YouTube video from the CNCF. People can go watch if they want. And in that replicator pattern, you basically fetch the data from the various sources and load it into the agent, and then you query the agent. Netflix, unfortunately, didn't open source what they've built. So we took it upon ourselves to do so with Opal. And so Opal became the kind of like, I guess, the de facto way to manage a lot of OPA instances and keep them up to date in real time. Another one of its advantages is a zero trust kind of layout. So each of the Opal clients or each of the microservices for authorization subscribes to updates through a pub/sub channel, a lightweight pub/sub channel. On top of WebSockets, they subscribe to the policy topics for the policy and data that they need, and for each they can have an access token. So each microservice for authorization only gets the data and policy that it needs. So you don't have this issues with data access across the space, and also the server itself, when you're using Permit is the Permit Cloud, doesn't have to have access to the data at all. So because it sends instructions on where to get the data, which can be completely local to you, and not the data itself.
Very cool. Okay. That's cool. As I was sort of looking, I was like, I thought Permit was handling sort of all these auth checks itself. And I was like, man, that's a very mission critical service, like super high availability, high correctness, very low latency to be doing it. And I like that sort of distributed, replicated pattern, like how it flips that a little bit. That's pretty cool.
So we decoupled the control plane from the data plane. So the data plane remains with you, but we manage all of its intricacies for you without actually being aware of what's happening inside it. So that gives you security. You don't expose data to us. We have at this point, most of our customers are healthcare companies. I don't know exactly why, but that's what ended up happening. And they're obviously HIPAA compliant, and there's PHIs, a lot of sensitive stuff. They don't need to share the data with us. It would create a lot more friction. So that's the first part, security. The other part is availability. So even if we're down, and we're not down often, but still, even if we're down, this doesn't affect the services consuming us at all, because it's all being handled locally. And as we touched also, it's really good for latency and performance, because all those queries are done locally, memory to memory, instead of going back and forth round trips around the cloud.
Yep. All right. Very cool. I love that. Okay. So I want to talk a little bit more about using Permit practically. And I know that you recently launched a new product called Permit Elements. Tell me about Permit Elements. What are they helping me with?
Yeah. So Permit Elements is really one of my favorite things about the product. So we kind of touched on all the things that you need to build for permissions or authorization. But primarily, when you think about it, authorization at the end of the day is a bunch of experiences that people need. And you've seen these experiences a billion times across a billion different applications, and you've probably built them yourself like a billion times. So think about user management with the ability to assign roles, API key management, secrets management, audit logs. So all of these, instead of building them on top of Permit, you get them ready-made. If you want to have user management in your application now, you go into an editor where you can customize how you want this to look and feel, and how you want this to behave in terms of permissions for the permissions. I'll double click at it in a second. You configure this, and then you have a snippet that you can plug into your code, and it's just ready to go. You don't have to do anything else. And you can always, I will say, you can always build your own specific custom UI on top of our API, or on top of directly talking to the policy engine. You can always do that. We never stop you from doing anything you want. But the main difference is that you don't have to, unless you really want to, and you probably don't, because this is not unique to any product. This is not unique to any application. We provide something that is more than good enough, that is flexible enough, that you can plug it in and forget about it. And there's also a lot of sub interfaces and experiences that are part of that. So for example, you build an audit log. How do you make sure that nothing is missing from that audit log? How do you make sure that you are rendering this in a way that it's easy for people to query and find the specific incident or issue that they have? You need this both for your own internal use, for your security and compliance, for example, or for your debugging, but also your customers. They want to know what happened in their system. If there's like an incident happened, they want to be able to see what happened, but of course, only within their tenant. So by working with Permit, you just get that out of the box without planning for it, without thinking about it. And you get it in a way that that works. A lot of times people specifically with audit logs, a silly mistake that people do there is that they report the audit logs as events separately from the action itself. It's just like another thing that you report. But then there can be inconsistencies between what happened and what you reported. So it's really important to generate the audit logs intrinsically from the permission checks. So that's one of like a best practice that you get out of the box by using Permit, and you even didn't think about it, or were aware that you need to do that.
Yep. I love like the first order benefit of this of just like, hey, everyone's building these same systems, and by having these templates, you can get that much quicker and do that. But then there's like you're talking about second order effect of like, as you're building out this system, you can look at the template, you can look at some of the stuff around it and be like, oh, I didn't even think of that problem as I'm building out this feature, like more of like a feature level thing for me that you've seen over and over as within the context of auth, but also the feature itself. So it's cool to, just ways to learn from people that have gone before you.
Yeah, and a lot of times there's also experiences that you want to have, but you don't have the time to get to them. For example, invites or approval flows. So the ability for like a user performs an action, another user approves it, or requesting permissions. User A can ask permissions from user B. You've seen these in all the advanced applications, but when you're building that application on your own, it can take you a while to get that. But it can improve both your business flow and the user experience with your application dramatically. And you can get that out of the box, which is the main thing here. And another thing that is tightly coupled with this is authorization for authorization. I already kind of mentioned it a couple of times, so I better explain this by this point.
Yeah.
So first of all, up till recently, ironically, in Permit, when you use the product, you invited other users, you only had one role because of the recursive challenges of authorization for authorization. So being able to decide what users in the control plane for access control can do, that's authorization for authorization. And I think just saying those words, you can see how mind-boggling it can be.
Yeah.
And so we'll be gradually enabling you to completely use the permit policy editor for defining who can use the permit policy editor. But for now, and also as kind of a good baseline for people that don't need the full power, you have the ability to map the roles that you create in the application, the roles that you can create dynamically. You can map them into meta permissions. You can map them into who can change the permissions, who can see what roles are available, who can assign those roles, who can see this user management interface or invites interface that you've created. And again, that's now something that you can do with drag and drop, but it gives you a depth of complexity that otherwise would probably take you a long time to get to. I don't want to it's months. Let's be honest, it's months, maybe more, but I don't want to push the point.
Yeah, for sure. Okay, one last question just around auth, and I want to talk about your background briefly. But okay, we talked about sort of the chronology of sort of access control, right? And often you see the admin, not admin, super admin, ACLs, RBAC, ABAC, all that stuff. Should if I'm building a new product, should I sort of slowly go through those or something like that? Or should I start with ABAC, RBAC, REBAC, one of those right? Does it make sense to sort of start at the end, or does it make sense to sort of progress through those?
So I think it really depends on what you're building and what are your priorities at this point. I wouldn't jump on any policy just because you think you need it, because anyways, it's probably going to change. Even if you think that this is the right flavor for you, it's a matter of time until another customer or another stakeholder or colleague comes in and asks for something that you haven't thought of. So for example, I mentioned that at Rookout, I built this 5 times. One of those times was when a business partner, Cisco, that is also selling Rookout to the market, at one point they came in and said, we want our own back office. And I was like, I didn't think of that one. Yeah. Life has a tendency to surprise you. And if you try and map all the things in advance, you'll probably waste a lot of time and you'll end up building the wrong things and not actually build the core things that you need. So in general, if you're a startup or if you're a company that's want to move with high velocity, focus on what you need now. And what I do recommend, though, is to set the ground in a way that will make it easier for you to upgrade. So one easy way to do so is to work with a solution that already bakes in the best practices, or you can follow those best practices yourselves. And there's on YouTube, you can find a talk that I gave at OWASP covering those best practices. But to recap quickly, you want to decouple your policy in code. You want the microservice. You want to have a microservice for authorization. Even if it initially just returns true for every query, you want to have that separation so you don't end up having drift in your code. Like once you plug it into the application itself, it's the authorization logic and the application logic start to merge. Like a developer comes in and says, "Oh, I just need another if condition here, and I'll just add it there. It's no biggie, right?" But then it piles on, and you come in like half a year later, and now you need to refactor everything line by line just to move from between models. But if you do that decoupling and you use policy as code, and you manage this in a real-time fashion that enables you to synchronize the data that you need when you need it, you'll be able to mutate or upgrade your application and your authorization layer separately. And then moving between models, moving between RBAC and ABAC, that's going to be a lot easier for you. Instead of taking months, it will take you like days or weeks at most.
Very cool. Okay, sounds great. Well, I just loved all the way I'm getting sort of brain dumped on the authorization, authentication, all this stuff. That's great. I want to talk about your background. You know, you're a serial founder. I've started a few different companies now. Rookout, as you mentioned, even ones before that. I like, number one, what have you learned? You know, this is now your third or fourth rodeo here. What have you learned in terms of being a founder?
Oof, so much. What a pick.
Yeah.
So I think maybe I'll touch on things that I think that a lot of times founders that I talk to miss. I think a common one is the difference and importance of product market fit and go-to-market fit. So product market fit is that your product jives well with your end users. They want to use it. They want to use it the way you present it. It solves their problem, it brings them value, and they engage with it in a good way. By the way, both of these fits are things that you aspire to. You never get to product market fit. You never get to go to market fit. Those are things that you gradually, in an infinite way, constantly try and improve. So product market fit is your product jives with the people using it. Go to market fit is your product connects with the market. Your company connects with the market and communicates it in a way that gets people to discover and use your product. You can see that the two are connected. If people discover your product, but they're unhappy with using it, so you have go-to-market fit, but not product market fit, you're going to have a bad time. If you have an amazing product that people that use it really, really enjoy, but no one wants to learn about it, no one discovers it, you're going to really have a bad time. And you need to kind of evolve these two around the same time, gradually, so they kind of go step in step with one another. Yeah. I think that's one of and a lot of time people confuse this. They don't know which one's which. It's kind of like authorization and authentication. Yeah. Like they sound alike, and there's elements that are alike, but they're in fact, they're very, very different. And if you don't get them right, nothing's going to work.
Yeah. I want to ask more about go-to-market fit, and especially for you. You know, you've started multiple developer-focused companies, which I think is a hard market to. It can be a hard market to reach, right? Where developers are sort of skeptical of marketing, at least in some way. Mm-hmm. And it's not saying you can't market to them, but I guess like how do you market well to developers and find go-to-market fit to developers?
That's a terrific question. First of all, maybe I'll start with why. You say it's harder. Like a lot of Israeli founders like to just do cybersecurity. You go, ooh, there are monsters in the wires. If you don't use this product, something is going to come and bite you in the ass. I hate that. I hate, even when I know that I have good technology to solve like an attack vector, I hate the fear mongering that you a lot of the time need to get to. In the end of the day, I think if you want to build a good product or a good company, you want to do so with empathy. You want to create something that touches on a problem that you experience yourself, something that you actually care about. That way you also, you're in sync intuitively with your customers, and you're doing something that you're internally happy with because you're solving something that you actually care about. So it's a win-win. It might be a harder play to do overall, but for me, it's not just about the money. It's about building things that I care about. And I think it's better for the soul, let's say. In terms for marketing to developers, I think the best advice I can give there is not to market to developers. In general, I think nowadays you shouldn't market to anyone. You should build things that actually bring value. You should actually do things that promote solving the problem with your product or in general. I saw an interview on a different podcast with the Lex Friedman podcast. They interviewed Mr. Beast, and he asked them, how do you create videos that a lot of people want to watch? And the answer there is, in the end of the day, you just create good videos, like create something that people want, and that will work. It doesn't mean that you don't need to promote it. It doesn't mean that you don't need to find a go-to-market fit for it. That needs to be part of the design. You need to find a way to put it out there. But if you focus on building something valuable that people actually want, they'll want to talk to you about it. They'll be looking for it anyways. And then you just need to put it in the right place, in the right way for access, and it will grow from there.
Yep. How do you think about education as part of that motion?
So first of all, you shouldn't be patronizing. If you're coming in saying, I need to educate the market, I need to teach everyone what's the right way to go, then, well, people are not going to be, especially developers, they're not going to jive with that. But if you go and say, hey, I have some insights. I've explored this space. I've went through the problem myself. Here are some things that I think are interesting. Let's talk about them. Here are some tools that I've built that I think that can help you. People respond well to that. Yeah. And I think in the end of the day, it also creates healthy relationships. Like if you were coming in with an attitude of you want to help, and that's actually what you want to do, as opposed to, oh, I'm going to trick you. I'm not actually here to help. I'm here to get you to buy something and like do a bait and switch. First, so especially with developers, but I think modern humans in general, they're not idiots. You might fool some of them for a little while, and you're not going to fool everyone all the time. So it's better to actually bring in good intentions and good value and focus on communicating it the best way you can. And most of the rest will not automatically sort itself, but will emerge out of this. You'll be able to discover where things work well and build on top of that and kind of double click on the things that work.
Yeah, absolutely. I totally agree with you. And yeah, like you're saying, you can't educate in like a patronizing way. I know better than you, but just being like, I've been here and shared this stuff. And, I've looked at a lot of the stuff on the permit site and blog, and just like, man, I had a lot of questions about auth that are tough. Looking through that has been great. Talking with you for the last hour has been really great, and like figuring out some of this auth stuff. So I appreciate it. I appreciate the honesty on like when it's a good fit, when it's not, all sorts of stuff like that. So thanks for coming on. For people that want to find out more about you, about Permit, how can they find out more?
Yeah, so about Permit, it's easy. Just go to permit.io and social media, Twitter, Reddit, elsewhere. GitHub, you'll find it at permit.io. If you want to approach me, and I encourage you to do so, I'm very open. People are kind of often surprised. Often I respond like on LinkedIn and elsewhere. I'm Weis, Orweis on LinkedIn, GitHub, Twitter, etc. Shoot me a message. I'm always happy to chat to fellow developers, security practitioners, entrepreneurs. So test me out. You'll be surprised. And I think the easiest way to talk both about Permit and with me is in our Slack community. So if you go into permit.io, there's a Slack icon on the top that brings you into our community, and you can just DM me there or talk to the rest of the Permit team there.
Awesome. Sounds great. So, co-founder, CEO of Permit.io, thanks for coming on. I really enjoyed this discussion.
Thank you very much. I had a blast.